Good morning, good morning, students. Today we are going to discuss the IIT-JEE NEET Foundation. The topic is under the heat there is a calorimetry. See, the heat and heat related things like the calorimetry is the branch of science. Calorimetry is the branch of science which deals with the heat and its quantities. Heat is a form of energy which transfers from high temperature to low temperature. Heat and temperature, these are heat is a cause, temperature is an effect. Heat is a cause, temperature is an effect. Heat is the amount of heat, so depends upon the mass of the substance. The amount of heat depends upon the change in temperature. So the specific heat, important one is specific heat. See, specific heat is nothing but the amount of heat required to change its temperature of 1 degree of a unit mass of substance is called specific heat. Means if you take a 1 gram of any substance, so that 1 gram of substance you want to raise of 1 degree centigrade, how much heat it is required? That heat is called specific heat. The specific heat, so these type of quantities like the change in temperature and the specific heat and heat, all this comes under the calorimetry. Specific heat is nothing but the amount of heat per unit mass per unit degree raise in temperature. The amount of heat per unit mass per unit raise in degree raise in temperature is called specific heat. So the relation between heat and temperature changes usually, okay, so due to the phase changes. What is that phase change? We'll see. The relation does not apply if a phase change is encountered. So because of the heat is added or removed during the phase change does not change the temperature. See, what is the meaning of this? Just this statement is here. Of course, before that, so Q is equal to Cm delta T, where C is called specific heat. In some books, S is also written. Specific heat, M is the mass of the substance, delta T is change in temperature. Q is equal to Cm delta T. The specific heat of water is 1 calorie per gram centigrade. The specific heat of water is 1 calorie per gram centigrade. That value in terms of joules, that is 4.186 joules per gram centigrade. 4.186 joules per gram centigrade. See, this is the higher than any other common substance. The specific heat of water is the higher than any other substances. That you should understand. See, as a result, water plays an important role in the temperature. Water plays in the temperature regulation. In the temperature regulation, water plays a very important role. The specific heat per gram of water is much higher than, so compared to any other metals. If you take other metals specific heat, that all we'll discuss later. The specific heat of solids, stables, we'll discuss just what is the phase change, all those things we'll discuss here. See, just if you take, there is a water having a temperature at minus 20 degrees centigrade. Let us say there is a water, or you can take ice at minus 5 degrees centigrade. This you converted into steam, the steam at 120 degrees centigrade. So in this process, if you observe, ice at minus 5 degrees centigrade and steam at 120 degrees centigrade. See, what are the changes will be there to convert ice into steam. To convert ice into steam, what are the different stages? Just see, first of all, let us take ice will be, see, the ice at minus 5 degrees centigrade will be changes to ice at 0 degrees centigrade. Ice at 0 degrees centigrade. This is the one important point. So, ice at minus 5, it means there is no change in the state. There is only change in temperature. Here, minus 5 converts into 0 degrees centigrade. This is 0 degrees centigrade. Then, ice at 0 will be converted to, See, ice at 0 degrees will be converted to water at 0 degrees centigrade. Water at 0 degrees centigrade. This is the another change. So then water at 0 degrees centigrade converts into water at 100 degrees centigrade. Water at 100 degrees centigrade. See, water at 100 will be converted to, so 0 to 100, and water at 120 degrees it will be changed. Water at, see the change is 120, water at 120 it will be converted. Then water at 120 will be converted to steam at 120 degrees centigrade. Steam at 120 degrees centigrade. See, these are the total changes. If you observe, ice at -5 will be first reaching to ice at 0 degrees centigrade. What is 0 degrees centigrade? Melting point. The melting point of ice is 0 degrees centigrade. See, ice at 0 will be converted to water at 0 degrees centigrade. In the first stage, if you observe carefully, ice will be changes to ice only, but change in temperature -5 to 0 degrees centigrade. So in the second stage is ice at 0 will be changed to water at 0, means there is no change in temperature, but there is a change in the state. There is a change in the state, no change in the temperature. In the, let us take, this is the Q1. See, this is Q1 and this is Q2 and this is Q3. In all cases, there is certain heat is required. So there is, if you observe carefully, when there is no change in the state, there is only change in temperature, we have to use this formula. Q is equal to Cm delta T. Q is equal to Cm delta T. But in the second case, if you observe, ice at 0 and water at 0, here there is no change in the temperature. There is no increase of temperature or decrease of temperature. Temperature is constant, but there is a change in the state. So here is also certain amount of heat is required to convert this. That heat is called hidden heat or latent heat. The latent heat is nothing but the amount of heat required to change its state from solid to liquid without raise its temperature. The amount of heat required to change it from solid to liquid without raise its temperature is called latent heat. Here Q2 is the latent heat. Q2 is the latent heat. When, see, Q1 is there, so that is change in temperature. Wherever change in temperature, you can straight away you can use this formula, specific heat of that substance, and you can use how much mass it is there. But in the case of Q2, we have to use this formula. Q2 is ml. ml is nothing but L ice you have to take. Latent heat of ice. What is latent heat of ice? So latent heat of ice is nothing but the amount of heat required to change its state from ice to water without raise its temperature, that is latent heat of ice. So latent heat of fusion of ice is, that is 80 calorie per gram. That's a constant value. L ice is 80 calorie per gram. It means that if you take